In previous class, we completed exercise 12.1 in the chapter Applications of Trigonometry. And before going to start next exercise, we need to discuss that which type of problems we are going to solve. Okay. In previous exercise, we have solved the problems incurred with only one triangle. But in forthcoming exercise, we have to solve the problems that involve two triangles. The figures for these problems are like this. Are you observing? Watch carefully. So we are going to face this type of figures now. The point to identify in all these figures, in every two triangles, there is a common side. Okay. For example, in these two triangles, this side is common. In these two triangles, the base is common. In these two triangles, the base is common, like this. Okay. For example, take one figure. In this figure, tan C is equal to h by x. Okay. Tan C is equal to opposite by adjacent. That is h by x. From this we can write h is equal to x into tan C. From triangle ABC, we have written tan C is equal to h by x and h is equal to x into tan C. And from triangle ABD, tan D is equal to opposite by adjacent. That is AB by BD. Here the BD is equal to sum of the x and y, that is x plus y. So tan D is equal to h by x plus y. From this we can write h is equal to x plus y into tan D. First we got h is equal to x into tan C, and now we got h is equal to x plus y into tan D. That is, the values of these two are equal. So by equalizing these two, we get x into tan C is equal to x plus y into tan D. Like this, by equalizing these two sides, we solve many problems. Okay. It is not meant that all the problems will be the same, but many problems will have to be solved in this manner. Okay. Okay, students, shall we start next problem, next exercise? So exercise 12.2. So the first problem is a TV tower stands vertically on the side of a road. From a point on the other side, directly opposite to the tower, the angle of elevation of the top of tower is 60 degrees. From another point 10 meters away from this point, on the line joining this point to the foot of the tower, the angle of elevation of the top of the tower is 30 degrees. Find the height of the tower and the width of the road. That's the question. Okay. So first imagine the scene. So here it is a road and a TV tower stands vertically on the side of a road like this. Now, from a point on the other side directly to the opposite to the tower, an observer here is there. And now the angle of elevation from this observer of the top of the tower is 60 degrees. And now it's given that from another point 10 meters away from this point, on the line joining the point of to the foot of the tower, the angle of elevation of the top of the tower is 30 degrees. That is, angle of elevation decreased from 60 to 30. So we can tell that the observer walked away from, that is, opposite, in the opposite direction of tower. Okay. Now the angle of elevation is 30 degrees. Okay. If going towards the tower, the angle of elevation will be increases. and in the going in opposite direction, angle of elevation will be decreased. So this is the scenario. Now it is asking that what is the height of the tower and what is the width of the road. Okay, so draw the figure for this scene. Here it is the foot of the line joining foot of the tower and the points of observers. Okay, let us draw the figure in lines. Okay, this is the picture. Now take the top of the tower as A and the bottom of tower as B. Points of observers are C and D, and here we have 90 degrees angle. CD is 10 meters. The distance between the observation points is 10 meters. Okay, height of the tower not given, so consider it as H. Assume that it is H, and let the distance BC be Y, X. Okay, height of the tower is H, and the distance BC is X. Now let us write AB is height of the tower, which is equal to H meters, and BC is width of the road, X meters. C and D are points of observation, and the measurements are given that angle ACB is equal to 60 degrees and angle ADB is equal to 30 degrees. CD is 10 meters. This distance only is given. Okay, now we have to find the height of the tower, that is H, and width of the road, that is X. Okay, so now first take the triangle ABC. So from triangle ABC, by taking tan C, we can write H by X, that is AB by BC. Now substituting values, C is equal to 60 and AB is equal to H and BC is equal to X, we get tan 60 degrees is equal to H by X. That is root 3 is equal to H by X. H is equal to X into root 3. So take it as equation 1. Now take triangle ABD. From triangle ABD, again take tan, that is tan D is equal to AB by BD. Here BD is the sum of BC and CD, that is X plus tan. Now taking D as 30 degrees, tan 30 is equal to H by X plus 10. But we know that tan 30 is equal to 1 by root 3. So 1 by root 3 is equal to H by X plus 10. So after that, we can write H is equal to, we have H is equal to X root 3 from equation 1. Okay. So from equation 1, we have written H is equal to X root 3. Now, by simplifying, we get X plus 10 is equal to X root 3 into root 3. That is 3x. X plus 10 is equal to 3x. And from this, we can write 3x minus x is equal to 10. So that 2x equal to 10. So x is equal to 10 by 2, which is equal to 5. So we got the width of the road. Okay. Now from equation 1, we have h is equal to x root 3. That is h is equal to x into root 3, 5 into root 3. So the height of the tower is 5 root 3 meters and the width of the road is 5 meters. Okay, that is the solution of first question. So take second problem. A 1.5 meter tall boy is looking at the top of a temple which is 30 meter in height from a point at certain distance. The angle of elevation from his eye to the top of the crown of the temple increases from 30 degrees to 60 degrees as he walks towards the temple. Find the distance he walked towards the temple. Okay. So first imagine the scene. So here it is a temple, and we have a boy of 1.5 meter tall. Now he is looking the top of the temple at an angle of 30 degrees, and then he walked towards the temple and again observed the top of the temple that the angle of elevation is 60 degrees. Okay. Now it is asking that what is the distance he walked towards the temple. Okay. So in this problem, we have to notice one thing, that the height of the observer is given, isn't it? So we have to consider this point while solving the problem. So now draw the figure for this scenario. So this is the ground, that is base, and this is the temple. Now this is 1.5 meter tall boy, is the horizontal line. Now the angle of elevation from first point is 30 degrees, and after walking towards the temple, the angle of elevation became 60 degrees. Okay, height of the boy is 1.5 meter, height of the temple is 30 meters. So take A, B, C, D, E, F. Okay, AB is now right. Sorry, first AB is 30, and EF that we don't know is X. CF also we don't know. We have to find Y. And here we have 90 degrees. Now AB is the height of the tower, which is equal to 30 meters. CD is height of the boy, 1.5 meters. CE is horizontal line. C and F are points of observation. Now, given that the measurements are angle ACE is equal to 30 degrees, angle AFE is equal to 60 degrees. Okay, AB is equal to 30 meter, CD is equal to 1.5 meter. Here CD is equal to EB. So that we have written CD is equal to EB is equal to 10 meters. Okay. Let EF is equal to X meters. And CF is equal to Y meters. Now, AE, the distance AE is equal to AB minus EB, that is 30 minus 1.5 is equal to 28.5 meters. Now from triangle AEF, first we have to find X, after that we can find Y. Okay, so take the triangle AEF. In this triangle we have the angle and opposite side, and we have to find adjacent side. So the trigonometric ratio having opposite and adjacent is tan. So take tan F. Tan F is equal to AE by EF. So substituting the values, tan 60 is equal to 28.5 by X, because we have A is equal to 28.5. So that root 3 is equal to 28.5 by X. X is equal to 28.5 by root 3. Take it as equation 1. Now, take triangle AEC. From triangle AEC, again here we have the distance AE, and we have to find Y here. So take tan C. Tan C is equal to opposite by adjacent. Opposite to C is AE and adjacent to C is CE. So now substitute the values. Tan C, that is tan 30 degrees, is equal to AE is, we got 28.5 previously, and by EF plus FC. So 1 by root 3 is equal to, here we have taken EF as X, FC as Y. X plus Y is equal to 28.5 into root 3. But already we got that X is equal to 28.5 by root 3. So that substituting X equal to 28.5 by root 3, then we got Y is equal to 28.5 into root 3 minus 28.5 by root 3. So by simplifying, we got like this. Okay. So you know the process of the simplification. So finally, you got Y is equal to 57 by root 3. So as the denominator is root 3, we have to write 57 as the multiple of 3. That is 19 into 3. So now 3 can be written as root 3 whole square. So after cancelling 1 root 3, we get Y is equal to 19 into root 3. That is 19 into 1.732. That is 32.908 meters. So the distance he walked towards the temple is 32.908 meters. Okay, students. This is the important problem. So let's start next problem. A statue stands on the top of a 2-meter tall pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degrees. And from the same point, the angle of elevation of the top of the pedestal is 45 degrees. Find the height of the statue. Okay, students. So let us see in the picture. So here we have a statue stands on the top of a 2-meter tall pedestal. So this is the pedestal and this is the statue. Okay. Now an observer observed that the angle of elevation of the top of the statue is 60 degrees and the angle of elevation of top of the pedestal is 45 degrees. Okay. And here it is asking that what is the height of the statue. So now draw the figure for given scene. So base, and this line is representing the statue stands on the pedestal. So the part above the line is height of the statue, below the line is height of the pedestal. Now the angle of elevation of the top of statue is 60 degrees and the angle of elevation of top of pedestal is 45 degrees. Okay. So now take A, B, C, D. Here we have 90 degrees. Okay. And the measurements are AB is not given. Take it as H, which we have to find here. And BC is given. The height of the pedestal is 2 meters. So now let AB is the height of the statue, which we have to find here. Take it as H meters. BC is height of the pedestal, 2 meters. D is the point of observation. Now, given angle ADC is equal to 60 degrees, angle BDC is 45 degrees. So, here we have to find H. Directly, we cannot find value of H. So, first find the value of CD. And by taking the triangle ACD, then only we can find H. So for that, to find the length CD, take tan 45, tan D, from triangle BCD, take tan D. Tan D is equal to BC by CD. That is tan 45 is equal to BC by CD. So we know tan 45 is equal to 1, BC is equal to, so we can write CD is equal to 2 meters. We got CD is equal to 2 meters. But we need not to find CD here. Even though to find H, we must have to find the length of CD. Now take triangle ACD. From triangle ACD, tan D, that is tan 60, is equal to AC by CD, opposite by adjacent. Now writing the values, tan 60 is root 3, AC is equal to sum of AB and BC, that is H plus 2, and we got CD is 2. So that H plus 2 is equal to 2 root 3. So H is equal to root 3 minus 2. And by taking 2 common, we can write H is equal to 2 into root 3 minus 1. That is 2 into 1.732 minus 1. So 2 into 0.732, that is 1.464 meters. Therefore, the height of the statue is 1.464 meters. Okay, students. That's all for today. So, in next class, we are going to some more problems in this exercise. Okay, bye. See you next class.